Alright, here we go with this review sheet here. So make sure you check any factoring for a greatest common factor, right? So 2, 9, and 18 have nothing in common, no x's in common, so you're ready to factor that up. However you do it, you could do this puzzle method if you want. You get negative 36 and negative 9. So if you use 12 and 3, negative 12 plus 3, remember you got to divide them by 2. So you get x minus 6 and 2x plus 3, and then you're done. All right, over here, these all divide by 3 and x, so you got to take that out first, which leaves you with x squared minus 10x plus 24. All right, so then it's easily factorable. You got x's, what multiplies to 24 and makes 10. You got 6 and 4, so minus 6 and minus 4. Or you can make your puzzle again. Over here, they have an x squared in common, which leaves you with 9x squared minus 16. Well, this is the difference of two squares. So x squared would be 3x plus 4 and 3x minus 4. All right, for number 4, we are trying to plug negative 4 in for all the x's. So g of negative 4 is negative 4 squared minus 3 times negative 4 minus 8. So 16 plus 12 minus 8 gives you 20. G of 2x, so that means we're putting a 2x for all the x's. So 2x is getting squared, 3 times 2x minus 8. So you get 4x squared minus 6x minus 8. Over here, you're trying to put x minus 3. So you have x minus 3 squared minus 3 times x minus 3 minus 8. So if you square that out, you might want to write that over to the side. You know, write x minus 3 twice and FOIL it out. You get x squared minus 6x plus 9 if you work that out. Then the rest of it, minus 3x plus 9 minus 8. So you clean that up, you got x squared minus 9x. And let's see, plus 10. All right, and with these, you're just done here. Like, you don't have to factor these or try anything else. Like, you're just finished. Like, somebody wanted you to plug that in, and that's what you were supposed to do. And then you stop. Okay. All right, graph this piecewise function. So, if I were you, I would have a pencil to do this so that you're not messing up anything, and so that you can erase parts of it. Because the easiest way to do this is to draw and then erase. So 2x minus 4 starts at negative 4 and goes up 2 over 1. So if I draw that across my whole graph. All right, I draw the line. All right, but I only want the part of the graph before 3. So here's 3, here's my graph. I only want the left side of this. So I'm going to erase everything past 3. And because this 3 does not have an equal bar, this point where I'm at, 3, 2, is going to be open. Okay? All right, and then I want a parabola move to the right 4. So parabola move to the right 4 is right here, and parabolas go over 1, up 1, over 2, up 4, because there's no stretch or shrink on here. But this is 3, right? I'm sorry, that's 4. So I only want the part of the graph, everything for 3 and above. So only from like right here do I want the rest of the picture to the right. So now I know it starts here, comes down, goes over, and 1, 2, 1, 2, 3, 4. So I basically want this part of it. Okay, so there's a little gap right here that nothing's there, and so that's that. All right, down below, f of 3. So here's my picture. If I go to 3, the function is not here, it is up here at 6. If I go to 0, 0 is down here at negative 3. Negative 2. Negative 2 is right there at 0. And negative 4 is down here at negative 2. So write the equation. There are 3 pieces here. So f of x, oh, it's called g of x, I guess. And I need 3 pieces, 1, 2, 3. So the easiest thing to do, I think, is to literally go over here and write the equations. This is a line. It's y equals, it has a slope of 1, you know, up 1 over 1. So 1x. And then if I kept going, it would cross it too. So that's that equation, the line. This line here is y equals 4, horizontal line. This is a parabola moved down 3 spaces, so it's x squared minus 3. So you should know that from all your transformation type problems that you've done before in Algebra 2 and this year. All right, so this line, remember this is y equals already, so I just put x plus 2. And I have to name the area where it's for, kind of like this was right here. So it exists from everything behind -1, but not including -1. So everything less than -1. The parabola exists when x is -1 to 3. So the parabola, x squared minus 3, is for everything between -1 to 3, and including those because it's filled in. And then this equation, y equals 4, is if we are everything past 3. Okay. All right. So domain. So in a domain problem, you have to be thinking about like what's going to go wrong in your problem. So this problem would be illegal if the bottom came out to 0. So I can't divide by 0. A fraction can never be 0 on the bottom. So when I factor this, I get that the bottom would be 0 at -5 and 2. So basically, I do not want -5 or 2 to be part of my numbers that I'm allowed to plug in. So I don't want -5, I don't want 2, but I will take anything here, here, or here. So I need to write an answer that represents these areas. So -infinity to -5, not -5 itself, or from -5 to 2, or,
hello.
Hi.
We've got some snacks.
Okay. Hang on a second.
Come to you.
Oh, thanks. I was making a video.
I'm sorry.
Well, we just
Yes.
interrupted it.
Yes.
There. Thank you.
Thank you.
Make me nice and fat.
And your room feels good.
Oh, doesn't still, I'm out of air freshener, but you know,
But
it's probably just me, you know.
Still good, but it feels good too.
Okay, bye. See you guys.
Take 2.
All right, thank you. All right, sorry. All right, and then from 2 on. All right, so with the square root function. A square root, you do not want anything under the square root to be negative, right? So you make up a little scenario for yourself. You want this, x plus 4, to always be greater than 0, and you will accept it equal to 0 as well, because the square root of 0 is just 0. So you solve this. So only x's greater than or equal to -4 will satisfy you for this problem. Because if you pick something that is less than -4, like let's say you choose -8. If you put -8 in here, you get a negative, and you can't do the square root of a negative. So you want to write an answer that represents from -4 on up. So you want -4 to infinity. Okay, this guy. So same scenario. You want x squared minus 16 to be greater than or equal to 0. Well, these you can't solve normally. You have to factor and get your critical numbers. So it factors in x plus 4 and x minus 4. And so basically, -4 and 4 are your 2 important places. And then you do their test intervals, right? So you pick a number like over here, like -6. If you put -6 in here, that's 36 minus 16. That's greater than or equal to 0, so that's positive. If you put a number here like 0, 0 minus 16 is negative, and so you don't want that. And then if you put a number over here like 10, that's 100 minus 16, that's positive. So you will accept something equal to 0, so it means you could accept this or greater than back, and this and above. So you write your answer for that. Okay, all right, so number 8, getting into some calculus things. So in number 8, this function below exists for -5 to 6, so it stops here and there. It's not going off to infinity, remember. So what's the slope at 2? So I go to 2, there's my graph. Oh, it's a flat line, so 0. What's the slope at -1.5? So -1.5 is here, I go down. It's along this line. The slope of that line is 3. The slope at -3, it's another flat area, so 0. The intervals where the slope is greater than 0, so that means increasing areas. So it's here from -2 to -1, or it's also here from 0 to 1. And it's also over here, everything past 4. Oops, 6. Make that a 6 right there, because the graph stops at 6. I should say 6. All right. Okay, in number 9 here, So number 9, we have a continuous function. It's from -7 to 5, and we want to know the area between the function and the x-axis. So we're doing the integral, but and that's what this notation is saying too. So from -7 to 5. Remember, anything above is positive, anything below is negative. Okay. So this little section right here, we got a triangle, right? So it's going to be negative because it's underneath. A triangle is 1/2 the base times the height. So the base is 1, 2, 3, 4, 5. The height is 1. So 1/2 of 5 is -2.5. So I'll start my list. All right, the next part is positive. So it's a circle. So the area of a circle is pi r squared, but this is only half a circle, so 1/2. So I have 1/2 pi. My radius is 2. So that's 4 times a half, that's 2 pi. The next little part is a little triangle. So the base is 1, 2.5. So a triangle is 1/2 the base, and the height is 3. All right, so when you put this in your calculator, 1/2, 2.5 times 3, you get 3.75. Let me just make sure, because I did this wrong earlier, and I just make sure it's right. Times 2.5 times 3. Yeah. So plus 3.75. And then we have this little tiny little part right here that's below. So this little triangle right down here. So it's going to be negative 1/2. The base is 1/2, and the height is 1. So that's -1/4, or -0.25. All right, so total that all up. Look, you end up getting 1 from all these things here. So 1 plus 2 pi. All right, because you got -2.5 plus 3.75 minus 0.25. So that totals up to 1. All right, the x value where a function changes from increasing to decreasing is called a critical number. All right, because that is basically a place like a max or a min, but it gets a critical number. It's where your first derivative is equal to 0, because remember, it's a flat tangent line. The x value where a function changes from concave up to concave down. It's also called a critical number, but I didn't give you that as one of your choices. That is an inflection point. So like an inflection point on this graph would be like right about here. Because it's down, then it goes up, or vice versa. Using the graph in number 8 up here, which of the following x values is the slope of the tangent line equal to 0? So let's see, at 5. 5 tangent line's positive. 0.5 is right here. Nope, positive. 4. Tangent line is 0 there. There's your answer. And then -1.5 is back here, so that's positive. So 4. All right, this little bit here. So I have a figure here. It goes from -3 to 4. So remember, I am not going to be using infinities in my answers over here. I have horizontal tangents at -1, 1, and 3. So look, -1, 1, and 3. Somebody telling you that the tangent line is horizontal, they're telling you that these are maximum and minimums, like local maximums and local minimums. So obviously this is a min, this is a minimum, and this is a max, like local min and maxes, right? Okay. It's also known that the second derivative equals 0 at 0. So this part right here is telling me it's an inflection point. Your second derivative is 0 at an inflection point because you're going from up to down, and it happens again at 2. So right there. So concave up, concave down, concave up. Okay, increasing. So this graph is increasing in this section and that section. So -1 to 1, or 3 to 4. And that's also when your first derivative is greater than 0. Same answer. Decreasing, so that's this section, so from -3 to -1, or from 1 to 3. When is the first derivative equal to 0? Well, that's when you have horizontal tangent lines, so it's these places right here. It's the maxes and the mins. So at x equals ±1 and also 3. All right. Oh, When was the derivative less than 0? Decreasing. So -3 to -1 or 1 to 3. All right, inflection points. Well, we talked about that right here. That was these places given to you. So when x equals 0 and 2. When is the first second derivative equals 0? Like, look, you literally got told here. So 0 and 2. Concave up, this section all the way to 0. So from -3 to 0. Or also from 2 to 4. Down was here, 0 to 2. All right, second derivative greater than 0, that's what concave up means. And second derivative less than 0, that's what concave down is. Okay, another area problem here. All right, so the continuous function we got from -4 to 3 has 2 quarter circles. So circle, circle, all right, and a line segment. All right, so doing the area. So if I'm doing the area, I see that this part and this part, they cancel each other out because I got a negative and a positive, the same thing. So basically, I'm just going to be doing these 2 circles, quarter circles. This part here is a quarter, so 1/4. And the area of a circle is pi r squared. So pi, my radius, is 1, 2, 3. So basically 9/4. All right, and then over here, it's a quarter of a circle, so 1/4 pi. The radius here is 1, so 1 squared, so 1/4 pi. Okay, so 9/4 plus, oh, I'm sorry, whoops, that one's negative because it's below, so it's negative. So 9/4 minus 1/4 is 8/4, and that is 2 pi. All right, for the next part, I need my calculator. I got a parabola, we're gonna graph it, see all our answers here. All right. Okay, so we got -2x squared plus 4x plus 11. Okay. All right, so I can't really see the top, so I'm going to go ahead and change my window. The y value on top, let's make it 15, how about? Just because it's a good idea to see every place. All right, my x-intercepts. So second calc, number 2. And I want to tell the calculator to look like right in here. So I'm going to tell the calculator to look between -2 and -1. So I'm going to literally type in -2, and then I'm going to type in -1, and you see how he gives me a little area, so that I press enter. Okay, so he told me -1.5. 1.6. Why did I say that? Hang on, let me make sure I type this in right. -2, 4, and 11. Yeah. All right, for some reason I had 1.6. All right, negative, I guess it's 1.5. Let's see, and this one over here is between 3 and 4. So second calc, number 2. 3 and 4. So 3.5. I guess I was looking on Desmos or something. I don't know what I was doing. All right, the maximum point. So this guy right there. So second calc, it's a maximum, number 4. And this time we can use our blinker. So I need my eyeball blinker to be to the left. So it's on the left. I'll go over to the right. There's enter and go past it. So 1 and 13. Okay, find the value at -2. So you have a couple places you could go to the table, and there's the answer at -2. Or you could be on the graph and press trace and then type in -2. There's the answer there. There's lots of ways to do it. Or you could press alpha trace y1 of -2. Any way you want to do it. All right, what's the coordinate of the y-intercept? So the y-intercept is, you know, when you're touching the y-axis, right? So you can press trace and do 0. So 0, 11. You can look at the table, 0, 11. Or you can literally plug 0 in for x and get 11. So you just have to know that. All right, so we want the slope of the curve. So we want the derivative at 3. So I'm going to be pressing second trace. Here's my derivative, number 6. And I'm going to tell them to do it 3. So there it is, negative 8. And I was expecting down, right, negative. What's the derivative at 1? So 1, oh, 1 is that tippy top, that maximum point. See that maximum point? So I should get 0. So second calc, number 6, type in 1. Yep, we got 0, good. And the reason it's 0 is because the slope of the tangent line at a maximum is 0. Okay. All right, the area under the curve from 0 to 3. All right, so here we got to do second calc, and then number 7, the area under the curve from 0, enter, 3, enter. And it colors that in, so 33. And you know, like usually you want to do the whole space, but whatever, like this is just like learning the buttons. All right, and I want to find the 2 points where this curve intersects 2x minus 1. So let me go back to y equals, type in 2x minus 1. And that black part's still on there, but that's fine. So I do second calc, number 5. Just hit enter 3 times. It'll just do the one closest. So there it is, negative 2 and negative 5. That point. And we're also going to get another one over here. So second calc, number 5. And let's see, we've got to move over closer to that place. So once you're closer, just hit enter 3 times. And there's that one, 3, 5. Okay, that is it. Good luck.